Hello, Namaste. I'm Ekbadur Guru. This video is designed to help SEE preparing students during lockdown period. The video is related to Unit 1, the force of subject science of grade 10. So, let us start the solution of problem without wasting of time. Let us look at this problem. To find change or the effects in force of gravitation between two objects when their masses are changed by k times the original mass, keeping the distance between them constant. So, you know that the force of gravitation depends on the mass and the distance. As masses as increases, the force of gravitation also increases. But when the distance is increases, the force of gravitation decreases. Okay, there's inverse relations between the force of gravitation and the distance, but there is a direct relations in force of gravitation and the product of masses. So we discuss here what change occurred in force of gravitations. Force of gravitations when the mass of the objects are changed, say k times, keeping the distance constant. Okay, to solve this, let m1 and m2 be two masses kept at a distance of d meter. Then by Newton's law of gravitation, force is produced between two masses. So let F be force of gravitation between two masses. Then by Newton's law of gravitation, F equals g times m1 into m2 by d square, where g is universal gravitational constant. No, universal gravitational constant is force of attraction between two unit masses kept at a unit distance apart. You know this? The value of g is 6.67 into 10 to the power Newton meter square per kg square. But in these solutions, we do not use the value of that g. So now come to the point, our solutions. By cross multiplications, we have g m1 times m2 is equal to fd square. Let it be questions 1. So our questions, once again look at the questions. The masses are changed by k times. So new masses now becomes k times the previous masses m1 and m2. So let masses be m1 dash and m2 dash or prime. So by question, m1 dash is changed by k times the original mass and m1, and similarly m2 prime is the another mass is k times the m2 prime, sorry, m2. Okay, so when the mass changes, then force of gravitation also changes by Newton's law of gravitation. Different mass has a difference, produces the different force of gravitation. So let the new force of gravitations, let new force of gravitations be F1. Then by Newton's law of gravitations, this F1 is given by g times m1 prime times m2 prime times whole by d square. F1 equal to g times m1 prime times m2 prime whole divided by d square. So since the value of m1 prime is k times m1, value of m2 prime is k times m2. Replacing m1 prime and m2 prime by k times m1 and k times m2 respectively, we get g k times m1 times k m2 times whole divided by d square, and k times k equals k square and g times m1 times m2 whole divided by d square. So now using relation 1, look at the relation 1, g times m1 m2 equal to f d square. We can replace this g m1 m2 by that relations. So look at here, this relations using here. So k square becomes k square times g m1 m2 is equal to, look at here, fd square. Where is fd square? Yes, fd square. So fd square by d square. Okay, fd square by d square. Look at here, fd square by d square. This g m1 m2 is replaced by fd square. So in numerator d square, in denominator also d square, so they cancel by 1. So finally we have F1 equals k square times F. The unit of force is Newton. So we write k square times F. So what we see here, the force of gravitation changes by k square times F. Hence required force of gravitation is k square times F Newton. Okay, this is the final answer. Now we have a particular solutions. Okay, and that particular solution, let us see this particular numerical problem. If 2 Newton force of gravitation is produced between two objects having masses 3 kg and 8 kg respectively, what amount of force of gravitation will be produced when their masses are halved, keeping the distance constant? Look at here. The distance remains unchanged while the mass is changed. The mass is halved. That is, the mass is 1 by 2 times the original masses. So there is change in the gravitational force. How it changes? We solve it. So Let us start the solution. Let m1 equal to 3 kg and m2 equal to 8 kg. This is the given masses, and the gravitations force of gravitation produced between them, that is F is given, it is 10 Newton. Okay, then F equal to G times m1 into m2 by d square. Okay, or from this what we write, G m1 times m2 equal to fd square. Don't put the values, okay? You find like this, fd square. So after changing the mass, or if the mass is changed, then force of gravitation also changes. So let the new force of gravitation be F1. Okay, and the change mass, the mass is half, the new masses. Okay, the mass is changed by half. So from questions we have m1, the first new masses are m1 prime equal to half of m1 and m2 prime equal to half of m2. Okay, and this equals and let F1 be new force of gravitations, then F1 equal to G times m1 prime times m2 prime whole divided by d square, and this equals G. Look at here, m1 prime is half of m1, so we write half of m1, and m2 prime is half of m2 whole divided by d square. So what we see here, 1 by 2 times 1 by 2 times, that is 1 by 4. Okay, 1 by 4, and G m1 m2 by d square. G m1 m2. Look at here. 1 by 2 m1 times 1 by 2 m1 m2. 1 by 2 times 1 by 2, 1 by 4 G m1 m2 by d square. So because this 2 and 2 is 4 and it is in numerator, so we write it, it is in denominator, so we write in denominator. So it becomes 4. The value of G m1 m2 is fd square. Fd square. Okay. So all by d square. So these two quantity cancel each other. So 1 by 4 times the F. F is already given. How much is that F? It is 10 Newton. F is 10 Newton. So we have here 10 in place of F. So on dividing it, it becomes 2.5 Newton. So thus the force of gravitations becomes 2.5 newtons. Answer. Okay, once upon, look at this problem. If 10 Newton force of gravitation is produced between two objects having masses 3 kg and 8 kg respectively, what amount of force will be produced when their masses are halved, keeping the distance constant? So uh, the distance is constant, but the mass is changed by k times, that is half, 1 by 2 times. So we solve this by simply, you know, without using the given mass, because we can use that mass also, but if we can be solve this problem without using the mass. So look at here, because the new mass is half times m1, another mass half time m2. So f1 equal to g times this one, and replacing these new masses by the 1 by 2 m1 and 1 by 2 m2, then you will get d square and 1 by 4 g times m1 into m2. Now in relation 1, g m1 m2 is fd square. In previous case, similarly, okay, as in previous case, we use the value of this g times m1 m2. In this type of problem, we do not need to put the value of m1 and m2. We can find without using them, like this. Okay. Thank you. I hope this video have satisfied you.